To all the energy conservation managers and ESG champions out there, greetings from Raghavan, ORPAC Systems, Chakan, Pune. I have 38 plus years air conditioning refrigeration industry experience. I manufacture industrial hot water heat pumps and customize the process chillers. Through this video series, I am trying to share whatever I keep witnessing during my industrial visits on the practical aspects of applying heat pumps in a typical industrial project. Through this sharing of information and knowledge, I hope it will be able to trigger more thoughts in you and help you to come out with some interesting project and outcome. We should work together to decarbonize as much as possible. In this episode, we are going to discuss about how to fully leverage and utilize all the benefits of a heat pump. So whenever we are talking of heat pump, the primary reason why it is there in first place is to generate hot water. Now taking a typical air to water heat pump, we are also generating cold air. So in addition to using the primary objective of delivering hot water, can we also get cold air that is available from the air to water heat pump? The answer is yes. So I will narrate some practical experiences that I have had which will help you to understand what I am trying to communicate. So there was a site where the heat pump was running for about 7-8 years. So the 𝐴𝐚𝐾 manager there said, the heat pump is running all right. Can we also use the cold air, put a duct and run it inside the factory premises to one of the cabins just to get free cooling. Now, if it is an existing air to water heat pump supplied long ago without any discussion with the heat pump manufacturer, we cannot simply put a duct and run it to any cabin. The reason is the air to water heat pump normally utilizes an axial fan, one or multiple, depending on the design. The axial fan characteristic is such that it generates lesser static pressure and they generate more air volume flow rate. That is why the axial fans are used there. Whenever we are running a particular length of duct with dampers, distributors, etc., typically how HVAC ducting is designed, it generates a lot of resistance to airflow. So whichever fan is there circulating the air, it should be able to overcome this much resistance created by the ducting network. So the fan usually, when in such cases, are generally centrifugal fans. Centrifugal fans can generate whatever static pressure we require and they can also deliver whatever air volume flow rate we need. So we cannot simply put a duct in an existing air to water heat pump and take it to space. It will lead to deteriorating performance of the hot water generation. But if at all we discuss with manufacturer beforehand, we will be able to design the air to water heat pump in such a way that if required, we can also use centrifugal fans on the evaporator side. In such cases, what usually could be done is place the whole air to water heat pump inside the space to be cooled. Let us say you have an assembly hall or an electrical panel room. So if there is available floor space, just to keep the air to water heat pump there. So it will keep taking the return air from that space, cool it through the evaporator coil and push it back into the room. So whatever cooling is available, that comes to the room only, the cabin only, occupied space only. Then the hot water will be piped out. Now one catch here is, if at all it is an occupied space, not an electrical panel room, the occupants may complain, I don't want the AC to run during winter. That normally happens. So if it is a air to water heat pump, during winter we cannot switch off the cooling, not possible. Because the temperature sensor is placed on the hot water side. Only when the hot water temperature is reached, the compressor will be modulating or it will be going on and off, etc. So the temperature control is on the hot water side. When it is running, whatever cooling we get comes to the cabin. or the aux space. Now during winter we cannot simply say switch off. If you switch off, there will be no hot water generation. But there is a way out. Assuming it is an occupied space or a particular shop floor area where workers are there handling the particular process, in winter they may have a problem. One way we could look at is in the outlet air itself from the evaporator, before where the ducting is connected, plenum and all is there, we can very well give another branch and totally duct out the cold air during winter time. We can put a damper actuator there, PLC programmed, automatic, or it can be controlled manually also. So whenever you don't want the cold air to come inside the space, that damper actuator will open, throw the cold air out. So this is something practically we have done. So this is very much possible. The next question comes is, can the air to water heat pump produce comfort condition like the normal air conditioners, like a split AC, VRF, ducted package AC? If we are designing it for that, it is possible. But if you simply take a air to water heat pump and expect it to deliver comfort condition, mostly it won't be. The reason is, the air to water heat pump evaporator side, it is designed for very high air volume flow rates. The reason is, it is designed for winter condition. Even when the outside ambient is 10, 12, 15, we want to generate 80-degree hot water. So they are liberally sized with a very low LMTD and a high volume flow rate. That is how they are designed. The air conditioners designed for comfort application, they have a particular CFM per ton. Of course, we do a heat load calculation and try to customize as much as possible. If it is a air handling unit application, if it is a ducted package or any other standard air conditioner, usually it will be whatever the manufacturer gives. We may not be able to adjust the CFM. The CFM is usually on the low side, 300, 350 CFM per ton. So there will be a difference. But compared to having an unconditioned space, at least the heat pump is able to drop the sensible heat to whatever extent, whatever free cooling is available from the heat pump. This way it will be able to manage. Now coming to the next question. Can we design the air to hot water heat pump to generate thermal comfort condition? Yes, we can. If you require 80 degrees centigrade hot water, we can go for a cascade system. So there will be two compressor, two refrigeration systems. One will be a typical air conditioning system design, generating thermal comfort condition on the evaporator side with that airflow rate, ADP, etc. And on the other side, it will be whatever heat this air conditioning system is giving will become the input for the next stage system, and that will be generating 80 degrees centigrade hot water heat pump. So these projects we have done, it is very much possible. Only thing is, this has to be discussed right before the purchase order is issued, right before the project is executed. Later on, it is not possible to do these kind of things. So I think whatever we discussed today is able to trigger some thoughts in you, maybe looking around and looking for more opportunities at your workplace. You may wonder why at all I have to do this. Some heat pump projects, when you do the ROI calculation and all, not necessarily it will work out to be a okay, go ahead kind of project right in the first instance. Because depending on the percentage runtime of our electric heater or whatever LPG hot water generator you are generating, sometimes the ROI may or may not work out. So in case you want to make the project on a fast track, utilizing the cooling available from the heat pump will make your project to happen, make the ROI a lot more interesting for the management to give approval. So I think this episode might have given you some information. So if at all you require more details, do give your feedback, comments, suggestions. My coordinates are given here. You can always reach to me. If you like this particular video series, do subscribe for my video. It will encourage me to come out with and share more of my experiences, whatever I have witnessed in industrial spaces. And I also request you to share this video with your energy conservation manager friends working in other industries. So together we can help all the industries to decarbonize and help our country to travel on the journey of net zero by 2070. Thank you so much. We will again catch up next fortnight on this particular topic. Thank you.